Okay, let's jump right into this explainer and uncover the invisible architecture powering the digital world around us. Have you ever actually stopped to think about what happens behind the screen when you tap a button on your phone? Well, today we're going to demystify databases. We're taking something that honestly seems incredibly complex and breaking it down into a really clear visual structure. By the end of this, you'll see exactly how your data is stored, managed, and manipulated literally every single day.
Here's our roadmap for today. We are moving from the massive macro environment of a database all the way down to the micro language we use to command it. We'll explore the invisible data engine, look at the 4 core objects in your toolkit, establish the strict rules for structuring data, and finally dive into querying and those powerful functions that automate all the details. Let's get to it. All right, Section 1, the invisible data engine powering the modern web. Before we look at the actual mechanics, we really need to understand the why. So picture this everyday situation. You're stuck at home ordering food on a delivery app. Right away, an invisible engine goes to work. Your app needs to instantly pull up product names, prices, categories, and descriptions just to make that transaction seamless. It is juggling thousands of moving parts, multiple restaurants, countless users, all at exactly the same time. Without a highly organized system running in the background, your app would absolutely crash under the sheer weight of all that information. And that brilliantly brings us to our core solution, the Database Management System, or DBMS. The DBMS steps in as the literal hero here to manage and organize these massive amounts of structured data efficiently. It's not just some static digital filing cabinet, It's a completely active system. It lets developers create new databases, change the underlying design or schema, quickly insert and update records, and most importantly, retrieve exactly the right data precisely when you need it. Moving right along to Section 2, the 4 core objects, your database toolkit. So now that we know why databases matter and what a DBMS actually is, let's imagine opening up a standard program like Microsoft Access and looking at the tools inside. What are the actual building blocks we use to make this engine run? Well, every Access database relies on 4 main objects to function properly. Think of these as the 4 specialized tools in your tool belt: tables, forms, reports, and queries. Each one has a very specific job, and they all work perfectly together to magically turn raw information into actionable insights. The table is your absolute foundation. Without tables, you just don't have a database. Tables store raw data strictly into columns, which we call fields, and rows, which we call records. And this isn't just a visual layout, it's a hard structural mandate. Each field is designed to hold one specific piece of information, like maybe a student's name or their class, and each record represents one complete entity, like all the information for that single student. But let's be real, staring at massive tables with thousands of rows gets overwhelming really fast. To prevent the absolute chaos of entering data directly into those giant tables, we use forms. Forms provide this incredibly clean, user-friendly interface. They let you input, update, and manage just one single record at a time, without accidentally messing up the rest of your precious table data. It's basically the front door to your data entry. Now, when it's time to actually show this data to your boss or a client, you definitely don't just hand them a messy, raw data table. That's where a report does all the heavy lifting. Reports take that table data, crunch the numbers, and format it into a beautifully organized summary that is 100% presentation ready. Next up, Section 3, structuring your data, setting the rules. Hold on though, before we can use those nice user-friendly forms or print out any elegant reports, we have to establish some incredibly rigid ground rules. Unlike a free-form spreadsheet where you can kind of just type anything anywhere, maybe put a number in one cell, a paragraph in the next, and leave 3 rows blank just because, a database table enforces strict rules. In a database, fields must maintain the exact same properties all the way down. You absolutely cannot have structurally empty rows or columns just for visual spacing. Structure is literally everything here. Because of this strict structure, we run into a really interesting challenge. What happens if 2 students have the exact same name? Say, 2 students named John Smith. How do we make absolutely sure the system knows they are distinctly different people and doesn't just overwrite their data? Well, we solve this by assigning what's called a primary key. This is a unique identifier, like a student ID number, that can never ever be empty or duplicated. But what if a single unique field doesn't exist? That's where a composite key, brilliantly steps in to save the day by combining multiple fields, like class and class number. So while there are lots of students in class 4A and lots of students with class number 21, there is only one single student who is class number 21 in class 4A. Combined, they completely guarantee uniqueness. To enforce these rules even further, we use something called an input mask. Basically, an input mask actively restricts exactly how users type in data. If you need an 8-digit phone number with a hyphen in the middle, the input mask guarantees that the user can only type it exactly that way. It's like having an automatic quality control gatekeeper for all your data.
All right, on to Section 4, manipulating and querying data, giving you the voice.
Once our data is safely structured, strictly governed by those primary keys, and cleanly stored through our forms, we need to actually interact with it. We need to learn structured query language, or SQL, to speak directly to the database. This brings us to our fourth core object, the query. Let's start simple. Using the asterisk in a select star statement, which you read as select all, tells the database to pull absolutely everything from the targeted table. So, select star from student retrieves every single row and every single column. It's the most basic way to ask the database, hey, show me everything you've got. Let's take it a step further and see how this builds. We rarely actually need all the data at once, right? So instead of using the asterisk to grab everything, we can select specific fields just by naming them. By typing select class, CNO, CNAME, we dramatically narrow our view, basically telling the database we only care about those exact 3 columns. But queries aren't just for retrieving static data. We can actually perform math directly inside the query right on the fly. It's super cool. For example, we can add score 1 and score 2, then divide by 2 to find an average. And notice how we use the word AS? We use AS to instantly rename that newly calculated column to average score, so it looks perfect when it outputs. Finally, we can filter our output down to highly specific records using a where clause. This is exactly how we find the needle in the haystack. But, and this is absolutely crucial, pay attention to the syntax rules here. Text strings, like the letter M for male, must be wrapped in single quotes. And dates, like April 1st, 2015, they have to be enclosed by hash symbols. The database engine is incredibly literal. If you forget one single quote mark, your query is going to completely crash. You have to speak its exact language. Almost there. Section 5. Powerful database functions. Automating the details. To make our queries even more powerful, SQL includes these amazing built-in functions. Think of them as a cheat sheet of pre-programmed shortcuts that automate data formatting and calculations, so you don't have to do any of it manually. On the math side, you've got functions like int to instantly round numbers down to the nearest integer, or ABS to find absolute values. And on the text side, it is an absolute goldmine. You can use len to count characters, upper or lower to instantly fix weird capitalization errors, and my personal favorite, trim. Trim automatically cleans up and removes all those annoying, unwanted spaces from the beginning and end of your data entries. Seriously, these functions will save you countless hours of manual data cleaning. Well, we've covered a ton of ground today, from the macro concept of a DBMs all the way down to the exact keystrokes of an SQL query. So now that you understand the strict rules, the 4 core objects, and the incredibly powerful queries behind data storage, I want you to ask yourself, what invisible database architecture did you unknowingly command today? Whether you were checking your bank balance, endlessly scrolling a social feed, or just ordering lunch, you were constantly interacting with these fascinating, highly structured systems. Keep looking for those hidden structures in your digital life, and I'll catch you in the next explainer.